Hello, everyone, and welcome to our QTEdu community demo day and the demonstration of new educational tools, instruments, and practices. Today, we are really happy to have Tamás Varga with us, and he will be presenting us his creation, which is a game and it's called Niel's Chess. And maybe in the beginning, he would also tell us a little bit about his path and how he came to this idea to design this game. So it will go like this. We will have half an hour presentation from Tamás, and then there will be questions and answers where you can write in the chat your questions, or you can raise up your hand and ask your question, and that's how we will progress. So, ready, steady, go. Tamás, the stage is yours.
Yeah, hello. I would like to welcome everybody. It's a pleasure to be here. Thank you very much for the invitation. My name is Tamás Varga, and today I will talk about Niel's Chess, which is a quantum game for schools and the general public. Just a moment. So here is the agenda for today. First, I give you some short introduction, including high level what Niel's Chess is. And then we are going to go into the details. I will tell you about quantum moves on the chessboard. And then I will talk about basically what skills you need to be successful in this game. And number 4, the variance is more for educators to give ideas how you can tweak the rules so that you can represent other quantum effects on the chessboard. So first, some introduction. First, about me. So I am a software engineer by training. I have more than 15 years of experience in the financial sector. And other than that, recently I did a postdoc in quantum software engineering at the Constructor Institute of Technology. And there I was working on a new quantum programming language in which you can put high-level data types such as numbers and text into superposition. I finished this postdoc end of August this year. And I am also very much interested in quantum technology education. In 2018, I created my website, is qedulab.com, where I post educational material. It is mostly intended towards people with IT background, just like I am, but I also have stuff for general audience. And this was where Niel's Chess was born, basically, that I wanted to be able to explain quantum concepts to people who don't necessarily have a technical background. So that's me. And now, sorry. So what is Niel's Chess? So it's basically chess with quantum rules. It starts in the same initial position as normal chess, and the same rules apply. It is just that the pieces are also able to move according to the rules of quantum mechanics. And what makes this special is that sorry, it's a traditional board game and no computer is needed. And I also hope that this game will help spread quantum literacy worldwide. I did some pilots, and as it looks, even children who are only 10 years old can easily learn the rules. And this game can also act as an icebreaker for the general public, so that by playing this game, they can basically start talking about quantum effects. So now let's go straight into the into the game. I will now tell you about quantum rules on the chessboard. So so here is a situation on the chessboard. You see that basically I would say black is in a better position. So now what can white do? So white can, for example, try to attack the queen, but the black queen, but of course the black queen can easily escape from this. Or maybe white can try to attack the black rook. But same story here, the rook can easily escape this attack. However, in Niel's chess, it is possible that you attack both the queen and the rook by a so-called superposition move. So let's see what it is. So here is now, so this was the superposition move, and now the white knight is on d4 and g5 at the same time. Or if I want to say it correctly, it's the position state of the knight is a combination of being on d4 and g5. And now the knight is attacking both the queen and the rook. So here is just an image what it looks like on the on the real physical chessboard. So you can see here a knight with a red mark on it and another with a blue. And when you see this on the chessboard, this basically means that this is one knight, not two. This is one knight in a special superposition state where it is on two squares at the same time. And the orientation of the marks actually matters, but in this presentation we will just assume that the marks always face towards the opponent. And for those who know more about quantum information, this here basically represents the plus state, the equal superposition of the knight on two squares. So this is what it looks like. Let's go back. So now you can see that the queen has escaped. So it moved from b3 to c4 because it is more valuable than the rook. So now white can try to capture the rook. So now what will happen? So the knight basically bumped into the rook, so it collided. And this collision will mean that now the superposition will collapse, and the knight will become classical again. So the knight will become normal again, and it will collapse either on d4 or on h7. And quantum mechanics says that this collapse is truly random. So nobody in the universe can predict where it will collapse. So that's why now white has to roll the dice to collapse its knight. So we roll the dice. It's a 5, and the rule is that odd number means blue and even number means red. So 5 is an odd number, which means that now the knight will collapse on h7. So let's see. See, the knight has collapsed. Now it's a classical knight on h7, and with that the rook has been captured. So now the rook is captured. But now you may say that, okay, I mean, chess is a logical game, but this was more like gambling, right? Okay, so let's see what happens when white is not lucky. So let's go back. So this was when white attempted to capture the rook. And now let's roll the dice again. So now it's a 4. So 4 is an even number. That means red. So now the knight will collapse on the red square, basically. And now the knight collapsed on the red square. Now the rook escaped. But it is not so it's still fine, because if you notice, the knight is basically protected by the queen on g1. So this attack by white, it was actually safer than just gambling. So let's see another situation which is similar. So here again, so the white knight will make a superposition move, and now it is kind of attacking the king and the queen at the same time. And this is a check because to spell it out, so now in a hypothetical next move, the white would have like a 50% chance of capturing this king. So the king is in danger, and in Niel's chess, danger means check. So the king is in check, so it has to move away. So the king escapes. So now it is not at risk anymore. And now white can try again to capture the queen. And now it will collapse because it has collided with the environment, and we know from quantum mechanics that even the slightest interaction with the environment can cause collapse, and here it does. So we have to roll the dice. We roll the 2. 2 is an even number, so it's red. So it will collapse here on d4. So the queen has escaped, but still the knight is safe because it is protected by the white queen. So let's see another situation. So here, if it was conventional chess, it wouldn't be possible to give a checkmate just in one move. But in Niel's chess, it is possible. I think you can guess what the move will be. It's a superposition move to c8 and g5 at the same time. And now the king is in danger of being captured. So this is a check. And there is no way out of this check. So this is a checkmate. But now you might ask, okay, but wait a moment. I mean, what if the black knight tries to capture the rook? What will happen then? So then what would happen is that the rook would collapse because now it has collided with the knight. So now it would collapse, and then it turns out that this move is actually not allowed. So it's bad luck for black. So this is not allowed because there is a 50% chance that the rook would collapse on c8. And if that happens, then it would leave the black king in check. And you know, in normal chess, in conventional chess, it is not allowed that you make a move that would leave your king in check. In Niel's chess, it is not allowed to make a move that would potentially leave your king in check. And that's why this move by the black knight is just not allowed, because it would potentially leave the king in check. So this was really a checkmate. So let's see another weird checkmate. So here, again, if it was conventional chess, we would think that, okay, this game is over, so black basically lost, right? This is a very bad situation for black. The queen would be gone very soon. And but in Niel's chess, actually, this is not a checkmate for black, but it's a checkmate for white. So white's king can be checkmated in one move, and the move is a superposition move by staying and moving at the same time. So now the queen gave the check to the white king, and the white king has no legal move to get out of this check. So it's a checkmate. And here is another weird situation. So now black has the move, the white king is in superposition, and now this is also a checkmate because now the pawn attacks the king, so the king is in danger, and there is, if you think about it at home, there is no legal move that the king can do to get out of this check. So this is also a checkmate. So it can be pretty dangerous if you put your king into superposition. Now let's go to the most complicated rule of the game, which is entanglement. So here the black knight is in superposition, and the white bishop can actually entangle with this knight. So, or in other words, it can join the superposition of the knight. So to do this, the bishop has to stay and move at the same time, but in a way that it gets close to the knight. And close means that it gets into an attacking position that symbolizes closeness. So now, for example, the bishop can stay on e2 and move to c4 at the same time, and then it can entangle with the knight. So let's see the move. So now the knight and the bishop are entangled, and this is indicated by rotating the pieces so that the mark is aligned along the same diagonal. So those pieces whose mark is aligned along the same diagonal, they form like an entangled group, like in general a GHZ state. And then to see what this means in practice in the game, so let's continue the game. So now the black knight moved, just for the sake of the example, and now the white bishop will also move. And then the black knight tries to capture the pawn. So now what happens is that also it bumps into the pawn, so the knight will collapse, but since it is entangled with the bishop, they will collapse together in a correlated fashion. So, and it is again truly random, nobody knows what will happen. So now black has to roll the dice. So it's 4. It's an even number. So remember, even number means red. So now the knight bishop pair will collapse on the red squares. So it will collapse to c7, e2. So let's see. It collapsed, and now the pawn has escaped, and the knight collapsed to c7, and the bishop collapsed to e2. And you can see here what Einstein called the spooky action at a distance, because actually it was the knight which collided with the pawn, and still this interaction also collapsed the bishop, which was actually far away. And this is the and this is the so this is the point of entanglement, that somehow it seems that the knight and the bishop were connected, although there was no visible or so no physical connection between them in some sense. So you see, they were like this, roll the dice, now collapsed, and then somehow the bishop knew that it had to collapse, and this was something that bothered Einstein a lot. He just called it spooky action at a distance. Yes. So and now let's go to the last rule, which is tunneling. So here the black rook indicates that it wants to give a check to the white king. So, and it wants to tunnel through the white pawn. And then, so tunneling, it happens in the quantum world, and usually, or typically, it's a low probability event. And that's why, so now we have to roll the dice. So black has to roll the dice, and only when it rolls 6, it can tunnel through. Otherwise, it will kind of bounce back and stay where it was. So now, of course, for the sake of the example, this is a 6, and then it can tunnel through, and now this is a check. So these are the basic rules of the game. And actually, just so these are the rules. I forgot to say something, or rather to point out something. Let me go just back to here to this checkmate. I just wanted to point out that here it's also this was not gambling. So this was not only luck. This is a checkmate, and here we did not even have to roll the dice, and we could give the checkmate with a quantum move. Okay, so now let's go to the next section. So I did some pilots with children. I did 2 pilots, 2 very small pilots actually. So the first one was with 4 kids who were aged between 10 and 12. And here first I basically introduced them the world of the atoms and subatomic particles. I played some YouTube videos for them. and I explained them this chess, that imagine that the chess pieces can behave like atoms, so that they can be in multiple places at the same time, and they can become entangled whatsoever. And then this, and then I posed it as a team competition for them, like 2 against 2, and then there were many puzzles which they really enjoyed solving. And then altogether it was 2 sessions, and altogether it took less than 4 hours to introduce them the rules of the game, and they could play the game. So they understood the rules. And then there was the other session with 2 teenager boys. Both of them were 14 years old. And here I did not use slides. I did not really introduce them quantum mechanics. So I just used the chessboard, explained them the rules. And it took less than 2 hours to explain them the rules, and they could actually understand them very, very, very fast. And especially one of them was a frequent chess player. He plays in a chess club, and after my introduction, he almost beat me in my own game. So I just wanted to say that these rules can be easily understood by children. Maybe they will not fully understand what superposition is, because nobody does, but still they will understand technically how to make the rules. And then just an example how to play this game, what I would recommend for beginners. So here is one example. It's a famous game. It was Magnus Carlsen versus Ernst in 2004. It goes by the name the Magnus effect. So I will show you the first 4 moves of the game. So first move, second move, third move, and the fourth move. And now suddenly white has the opportunity to actually checkmate the black's king. I think you already guess what the move is. It's a superposition move by the knight, and this is like a double check to the king. And if you think about it, black has no legal move to get out of this check, so it's a checkmate. So basically, this I would recommend for beginners to just start the game as if it was a normal chess game, but always look out for opportunities where you can take advantage of a quantum move. And then yeah, what skills you need to be successful in this game. So just very shortly, of course, logical thinking. This is inherited from conventional chess, and so it's basically all about navigating an uncertain and interconnected environment. So whenever there is an uncertain event, you have to make sure that you have a plan B, so that you are not just doing gambling. And you also have to have a judgment, or you will learn to have a judgment of what is a good risk and what is a bad risk to take. For example, here on the right side, you can see that just by the strength of the pieces, black's position seems to be a bit stronger. But now white has the possibility to actually try to capture the black queen. Now the question is this a good risk to take or not? I think many people would say that, yeah, it's a good risk to take, because then if the capture succeeds, then it's a checkmate immediately. So literally white has, with this move, a 50% chance to win. And of course, a 50% chance to move if the queen collapses here. But still, that 50% is actually more than the chances that white has in the current standing, based on the strengths of the pieces. So some people would say that it's a good risk to take, so go for it. But then other people would say that, okay, maybe I am more risk averse, or maybe actually I would have a good chance because my queen is not yet in superposition, while the black queen is already in superposition. So black lost this surprise factor that it can move to 2 places at the same time. So actually, I would rather just avoid this risk, and then I would just move with the knight here in between, and then there is no immediate risk anymore. And then I will figure out later how to use my queen to deliver a checkmate. And then let me talk about some variants. So this is more for educators. So basically, this Niel's chess it's a rich system of marks and rotations. And if you have any quantum effect on your mind, then chances are that if you give it a try, you will find a way to demonstrate it on the chessboard. And the limit is really the imagination. So for example, here you can see a superposition, but what is strange, or what is unusual, that the red mark faces the opponent, while the blue mark faces the player. And then the question is how to interpret this superposition. So there are various ways. So one way, which is kind of the official rule, is to interpret this as an unequal superposition, meaning that when this knight collapses, then there is more chance that it will collapse on the red square and less chance that it will collapse on the blue square. For example, when we roll the dice, if we roll 1, 2, 3, 4, then it will collapse. Hello? Yes?
Yeah. Buena atención, dice.
Sorry? Okay. Okay, I will just continue. So there will be more chance to collapse on the red square than to the blue square, so it's an unequal superposition. But there is also other way. For example, you can interpret this as an equal superposition with phase. So basically the minus state, for those who are familiar with it. So what this means is that so it is just there is a 50-50 chance, but still you can show that there is a difference from the from the plus state. You can apply here, you can introduce into the game the Hadamard gate and the Z gate, and you can really show that that superposition does not mean that the knight is either on B3 or D3. You can basically demonstrate that in some sense the knight really has to be on two squares at the same time. And you can also introduce quantum cryptography this way. So here is the typical setup: Alice, Bob, and Eve. And now let's say Alice and Bob want to share a secret. So Eve sends them a bishop in superposition, and then Alice and Bob will collapse this bishop. Now we know that this bishop will collapse onto exactly one of A4 or E4, and if it collapses to A4, so let's say they just come here and try to find it, and then if Alice finds it, then Alice will know that Bob didn't find it, and if Bob finds it, Bob will know that Alice didn't find it. So they will know, they will have like a secret bit in this way. However, Eve will not know what the secret bit is, because it is far away, and the collapse is truly random, so nobody in the universe knows. So what can Eve do? Eve can be smart and make an entanglement. And then now let's see what happens. So now the knight is entangled with the bishop. So now let's say Alice wants to collapse the bishop. And then, of course, it's random, truly random. So we have to roll the dice. So it's here up, it's a 3. So 3 is an odd number. So this will collapse on the blue squares. So they collapse in a correlated fashion, either to blue, blue, or to red, red. So let's see the collapse. So now they have collapsed. So now Alice found the bishop here. So she knows that Bob will not find it on E4 when he will be looking. And then kind of they think they have their secret, but actually they don't, because Eve will find the knight here, and Eve will know that if the knight is here, then the bishop must have collapsed to A4. So Eve will know their secret, basically. And again, just quickly back to the pilot. What was the biggest challenge in the pilot? It was isolation. So maybe because maybe I don't have much experience in teaching such small kids, I try to explain them how important isolation is in quantum physics. So I told them that look, if you have a superposition, even a single air molecule bumping into it, or light from the lamp or from the sun, can make it collapse. And that's why I told them that actually what you would see on the chessboard is not this, what you see here. It is not this. It is something like this. It's like a black box with a label. and then this really caught the kids by surprise. They didn't expect that. And then they started to doubt that superposition really existed, because they said that, look, if nobody can ever see superposition, why should we believe that it really exists? And this was really a challenge that maybe I should solve in the future. Okay, so this was my presentation, and thank you very much for your attention, and I wish you happy playing. And here you can see some contact information. So this is my email, and here is in the coming soon section. So currently I am making the game available online. It is not yet there, but I think sometime in the first quarter of next year it will be available on nielschess.com, so people can just go there and play the game against the computer. And we are also in the process of producing this game physically, so you will be able to buy it in some online shops. I think this will already happen in the first 1 or 2 months next year. And if you want to read the paper, which I presented this year in September at the QC 24, so this is the paper. But don't worry if you don't take a screenshot of this. Just Google for Niel's chess, and you will find everything. Yeah. So thank you very much for your attention, and yeah, I am happy to answer questions.
Thank you so much, Tamás. This was exciting to discover this new game. I'm already looking forward for the next world championship in the Niels chess. I am not a chess player, unfortunately, but I'm starting to learn because my kid wants to learn, and so I'm starting to learn. And this seems to be superpower. Let us see now if there are questions from the audience. Please feel free to raise up your hand or write in the chat, whatever is more comfortable to you. And in the meantime, I will break the ice with a couple of questions that I wonder now. For example, if you have a rule, how many figures can be in the superposition states at the same time of one player?
Oh, any. So there is no restriction. In principle, you can put all your pieces into superposition. But
And will the board allow it? I never made this count
yes, because you have 32 pieces at the beginning, and then each piece is allowed only to be in two places at the same time. So it would be 64. So in principle, all the 32 pieces can be in superposition.
Okay, that sounds like a fuzzy thing. So now the question is, if there are more pieces in superposition, how do you know in between which pieces there is entanglement?
For the entanglement is that so when they are only in superposition, I think I can show it like this. Then the marks are facing like vertically, so like towards the opponent or towards you, or like this. But when there is this is the normal superposition, and then when there is entanglement, they are rotated. They are like 45 degrees diagonal, and that's why you will see that. So you check the diagonal, and then if the marks are along this diagonal, this is like one entanglement group. It's like a big so it can be either two or more pieces entangled, because more pieces can join later. So imagine it like a big GHZ state, basically. And then since there are only two diagonals, so there can be one group with this diagonal and another independent group of this diagonal. So there can be like only two entangled groups on the chessboard, and this can also, like education wise, you can say that this represents that entanglement is a resource, and you cannot have more than two groups.
Scarce resource.
Exactly.
But you have the marks only on one side, so technically you could use all the four corners.
Yes, but I just wanted to.
But one is up and one is down. Okay, they have to face.
Yeah. So and I just wanted to keep it simple. So
that's really nice. Okay.
It's either vertical, horizontal, or diagonal, and that's it.
Okay. I'm checking for the hands and questions, so people are still warming up, and I was wondering about. Yes, so you said the entangled. Yeah, now you clarified with the angle. I had another question that ran out of my mind. No, okay. I think you clarified it all with this move. Oh, here's Abu. Abu, are you up for a question?
Yes. Yeah. Thanks for the presentations. I'm curious how many this quantum source also like superposition. Is there a limit, or anybody can enter any time and any moment?
Yes, anybody at any time. There is no limit. So the limit is only the geometry and the size of the board.
After several superpositions, maybe game is already finished, but maybe it's hard to verify. Have you thought about this?
Sorry, hard to what?
So we start to be in superposition both sides.
Yes.
Maybe at some point it's not easy to verify the game is already finished.
Oh, I think it is okay. It is more difficult to verify than in normal chess, but since the pieces are pretty much independent typically, that's why I think it is always it is always kind of easy to verify. Or if you cannot verify because you are new to it, whatever, then for example I say that it's a checkmate, and then if you don't agree, then I give you 5 minutes to figure out how to escape. So but to answer your question, my experience is that it is always relatively easy to verify if the game has finished or not. Yeah.
Okay, because on our computers we have some limitations to simulate like quantum circuits, like 20 qubits or 30 qubits.
Yeah, but this is much simpler than that, because here we put the individual pieces in the superposition, and it is like having, like, if you have like 20 qubits, imagine that you put all of them separately.
I know it's exponentially increasing.
But it will not be exponential because the entanglement that you can have on the chessboard is very limited here, and that's why it will not really become exponential, because there can be hardly any entanglement here.
Also regarding entanglement, like it's blue, red, but it's also possible one blue, one red, the other blue, other red is also possible. But this current version doesn't allow this, correct?
I did not get it.
So entanglement, the famous one is 0011.
Yes.
But 0110 is also entanglement.
Oh yeah. So the current version, okay. I have many variants, but in the paper, which this paper here references, I also have the variant where it is allowed, but in the official version that I will implement on the website, it is not allowed. You are right. Yes.
Okay, and this checkmate looks little like unfair to like the opponent. If it's attacked from two sides, you had one example, for example.
Yes.
Still it's possible. It can move, and then we can make measure maybe 50% loss, 50%. I don't know. It looks too much power, giving too much power to this attack person.
Yes, that is true, but my answer to this would be that both sides have this power. So black and white, so they start from the same initial position, and so if white gives checkmate like this, then I would say that okay, black, you could have done the same, right? So that's why I don't think it is too much power. It's a bit unusual, yes, but both sides can do the same, and and they just have to build up their strategy in a way that they will enjoy this unfair checkmate.
No, my point is, it's like if you think it's a two word. In one word, one move attack from here. In other word, attack is other side. But after measurement, only one of them indeed, win, and the other maybe really escape.
But here it's all about danger. So it's like a generalization.
Superposition, then it's finished. That looks little, I don't know.
So it's I mean, I wanted to avoid that I only end the game when the king is actually captured, because I feel that it is just not it just wouldn't look like really chess, because in chess you don't capture the queen, the king, but you just set it into a situation
like trap.
Trap it, and this is like a trap. It's a probabilistic trap, but it's a trap, and if you set up such a trap that the king cannot avoid, the king cannot get out of risk, then I think you deserve to win. So
my only concern is usually people, especially non-technical people, usually say quantum superposition, you are really in two places.
Yeah.
It is like parallel computing. They are thinking, I am really here, but I am really here. But usually you have a probabilities of them, like you have some weights, not like exactly you are there. This interpretation kind of like teaching that you are really in both of them. That's my little concern. Maybe now it's better. My concern, I can explain.
Yes, but I think it's it's about language also, that we can explain precisely what I mean when I say that it's both here and here. So in my interpretation, it means that okay, for example, if the knight is, or if a glass is on the table, it means that if I go to the table, I will find the glass. And then if the glass is on, and this is the classical interpretation, right? And now in a quantum context, if I say that the glass is on the table, what I really mean is that if you go to the table, then you will have a non-zero chance of finding the glass there. And then this is what I mean, that the knight is on two squares at the same time, that if you search on one square, you will have a non-zero chance of finding it, but if you search on the other square, you will also have a non-zero chance of finding it there. And this is my that's what I mean.
That I agree. But this approach, just a small critics, because you are also access to kids, general public, and also they will develop some intuition about quantum. They might think that I am really in both position, like fully, you understand? Usually we are there with some weights. So mathematically it's well explained, like I am here with 50%, I am here with 50%, and after measurement I am only in one of them. This is just a concern, I don't know. But yeah, overall, I mean, it's great. I am thinking maybe some simple games with similar ideas. Yeah, maybe then the board may be less complex. And
I mean, you can play this game also with a smaller board, actually. But on the other hand, about the superposition, I think I doubt that anybody really understands what it is, and there are competing interpretations. So if this topic comes up during actually it will come up, because I will just simply admit them that, look, I don't understand what superposition is, but if you measure it, then this will happen. So yeah. So
if some probability is possible, it's not checkmate, then it should be also visible. So in your checkmate, it looks, I don't know, maybe I'm the only one. Yeah,
it's a
maybe.
trap, basically. It's a trap. Yeah.
Thank you.
Thank you, Abu. That was really nice discussion and challenging, Tamás. I think we also have Yanis who would like to ask a question, right?
Hi.
Really nice. I like the presentation. And I don't know, I want to ask, are you familiar with the quantum chess from Christopher Cantwell? This online
and
that they have on Steam? I played this one.
Okay. So actually that was the inspiration, because back then when I first saw it, it was either 2019 and 2020. I don't remember anymore. And at that time I was about to make a course, a quantum computing course for IT people, and I got super excited when I heard about that. And then I went to the website, and to my surprise, I did not understand the rules. And and then I was thinking, okay, look, I mean, if I don't understand the rules,
at some point you had to pay also to play it.
no, but I did not understand at that time. It was not yet on Steam, and I did not understand the rules. And then later I came across the paper. They have a paper like 35 pages, and it was very difficult to go through, actually, to really understand what is happening. And that was when I saw that, hey, come on, it should be much simpler than that. And that version really needs a computer to maintain the superposition state, because it can be so complex. And this is also to Abu's concern, that so if you look at converse chess, it's a different philosophy, and things can get really complex that even you need your laptop to keep track of it. And this
yeah, I don't remember. Yeah. So he can be in more than two positions in superposition, right? You can be in more situations.
Basically,
than two.
Converse chess is more about like, you can imagine like parallel universes, like you have like classical positions in kind of in parallel universes in superposition.
No, let's talk about your version. So I like the fact that it has the physical pieces, and also to complement there with what Abu was saying, maybe you can introduce a decoherence mechanism, let's say with a timer, where the roll of the dice or the superposition will collapse by itself.
Oh yeah.
Ah, that's cool.
Yeah, no. So basically, the good thing about the physical game is that if you have any such ideas, you can just go for it. You can so you can do it at home. So with the official version, my intention is that it should be as simple as possible for everybody. Now, if I introduce this coherence concept, I think this can be maybe a bit too much for many people. But it's a good idea, and in the classroom, you can feel free to do that because that's how things really work, right? So
I really like this idea. I mean, it is the decoherence will be the time,
Yeah,
the
the
normal
time.
chess, there is always a time, no? And usually in the time you need to move. And here, in addition, with the time, everything will collapse just for
yeah,
simulation.
Put some pressure on the players.
yeah. So yeah, exactly. It's a
Okay,
good
thank
idea.
you.
Yeah, it's like after 5 moves, it will collapse by itself.
Yeah, but then you need an arbiter who will sit there and look and count.
Yes, yeah. But it's a nice idea, and yeah, I can include it in the variants.
Hmm. I was also thank you very much, Yanis, for the question. I was also wondering, like, so to have a possibility to collapse. The idea, if I understood you correctly, is that you need to face the possibility to get over someone's another figure, no? So you need an interaction to collapse.
Yes.
Otherwise, they will stay superposition. You can continue moving the figures that are in the superposition. They will move, let's say, together accordingly to the superposition. Or can you also change the superposition during the move, the next move?
Okay, so yes, so the Niel's chess, it is philosophically it is based on the Schrödinger's cat thought experiment, and you can just imagine that you have a piece which is in superposition, and imagine that you have like a protection layer around it, right? And then when this hits something, then this protection layer will break, and that's why it will collapse. And now for the change, so yes, there are variants in which it is possible that actually I even showed it when you interpret when one mark is looking towards the opponent, one towards you, and then you can interpret this as a minus state, and then you can apply the Z gate, for example, and then it will turn into a plus state. Or it's also possible when you interpret it as unequal superposition, there can also be that you can introduce in some variant an X gate, which will basically flip the two marks, the facing of the marks, and then if you say that the piece, so the piece which is looking forward, looking to the opponent, will have more chance to collapse into, while the piece which is looking backward, it will have less chance. And then if you apply the X gate, then you can basically just turn both of them, and then suddenly this will have more chance. So yes, it is possible. In the official variant, there is no such thing, but it is possible to introduce. Yes.
How did you think about the factual act of doing a gate? So you were saying like, I will give everybody a set of gates that you can then like play. Say, okay, I'm doing the Z. Okay, here's my Z. I'm doing it. So and then you flip it by hand, or how was the
No, just so if you have a variant in which you can do the Z gate, it will be just if you have a superposition like this, and then you have the move, and then you say that, okay, now I want to make a Z gate. You just basically take this, the blue one, and just turn it back, and then you have the minus, and then you have the minus state instead of the plus state, and then if you in the next move you can do it again, and then you turn it back, and then you have the plus state. And this is how I saw.
You just say it. It's not
Yeah, we just say it. Yes.
Okay.
Yeah, we just say it. Yes.
Okay, that's very nice. I'm really happy that we have got an occasion to have you showing us your game and also sharing a little bit of your future plans. Good luck with with your ideas of implementing the online version and also the selling version. I'm already having a client here that will order your game once it is online.
Yes, by the way, so if anybody wants to get notified, drop me an email, and then when it goes live or the physical game is there, I will answer you, and then you will know. Yeah.
Okay, that's great. That's great. So we will do it. So here in Trieste, for example, we have an association of physics students. They are all over Italy, and the Trieste section is present. And they have picked up the idea of Quantum Game Cafe. And now, whenever they know a new quantum game, physical quantum game is available, they are immediately buying it. So I will
really?
necessarily inform them about this.
Okay. I mean, if you know about physical game that can be bought, you can also send a list to me because there are not so many that I know of. But if you know something new, then let me know, please. Yeah.
Sure, I will post you our collection, our list collection.
Okay, thank you.
Well, then I think this is the moment to say goodbye and also to wish the good ending of the year and happy holidays. In addition to happy playing, as you're wishing on your slide, and Merry Christmas and Happy New Year. I think this is the first official time I'm saying it this year, and I'm happy it is in this nice atmosphere of the people who love sharing with other people and teaching, educating, and learning. I think this is the key word also among all of us here who are all educators, but we are always happy to learn about new things. And I tell you that next year we'll have already planned next session in January. I think it's 21 Tuesday, always Tuesday. There will be a Cureka box about quantum computing from Cureka. And I'm looking forward to see you back in January. And soon there will be announcement that you can register again. So thank you very much and have a great day.
Thank you, you too. Bye-bye.